Thank you very much for joining us this evening for exploring solar dashboards for middle school grades. My name is Samara Hamzi, and helping me with the presentation is my colleague Gina Smith. Both of us work at Wisconsin's K-12 Energy Education Program. And we have two guest presenters with us tonight as well, Mahr and Chris Mitchell, both who are 8th grade science teachers in Oregon Middle School, and they're also 2021 Energy Educators of the Year. So if you check out the KEEP website, you can learn more about them as well. And KEEP is accepting nominations right now for our next round of Energy Educators. So you can self-nominate, or if you know of a great teacher in your community or who you've worked with, please nominate them. And as you know, this training is being recorded. I'll send out a link to the recording once it's complete to everybody who's registered. And then once we edit it, it'll also be available on the KEEP website and uploaded to YouTube so that you can share it out. So as we, there we go. As we begin here, we would like to recognize that the University of Wisconsin Stevens Point occupies the lands of the Ho-Chunk and Menominee people. If we could take a moment, please, to acknowledge and honor this ancestral Ho-Chunk and Menominee land and the sacred lands of all Indigenous people. Thank you. And here at the KEEP is part of the Wisconsin Center of Environmental Education. It's we're like over 30 years old now. And we provide leadership and resources to advance education for sustainable human and natural communities. In particular, KEEP, our mission is communities making informed energy decisions now and for a sustainable future. And you can see on this slide who all of our funders are. I'll give you a quick overview of what we're going to be doing here. We have, we'll first be taking a quick exploration of the solar dashboard lesson that we have already available on the KEEP website, and which you hopefully have also received a link to in the confirmation email that you got earlier this week. But really, hopefully, the meat of what we're going to be doing and we'll be focusing on is seeing how Chris and Nate are conducting energy education in their classroom and at their school, and in particular, how they integrate solar dashboards in the classroom and some of the activities that they use. We'll take a look at a live solar dashboard, and hopefully we'll get lots of ideas and suggestions from all of you who are participating as well, so we can improve what we have and we can all just be better at our craft as well. So any questions before we get going or anything here? Anything in the for the participants that you hope that we would touch on that weren't brought up? All righty, sounds great. Well, let's go ahead then, and we can take a quick look at, not quick, but a brief, not a detailed look at the, I cannot get my clicker. I'm going to change this out. I'm going to make my pointer not whatever I have it at, because that is not working. It's super weird. I've never had that problem before. Okay, well, I can fix this problem all the same because I know where the link is, and I think that Gina is going to be dropping it into the chat as well. So let me hide my controls here. All right. Here we go. So this is the lesson that KEEP has available online that has been shared with you already. Can everybody see my screen okay? All right, great. I'm going to go ahead and take a look at it in tile view here, because really that's the level at which we're going to be looking at this, not going through it slide by slide. That's something you can definitely do on your own, but in the grid view, we can kind of get that. All right. That's not what we want to do, get that high level of looking at it. So it's organized around the 5 E's of engage, explore, explain, elaborate, and evaluate. So you can see You can see those are each highlighted at the tops of the slides here with some discussion that is built into it as well. Gina is the one who actually created all of these slides based on the work that we do internally, collectively here at KEEP. And all of our lessons are built around, we have our title slide, we also have acknowledgement of Indigenous lands that you could incorporate or not. And then there's a slide for teachers that has this icon in the bottom. So any slide you see with that icon is one that you, the teacher, it's meant for you, but you deleted. And for the entire presentation, you would make a copy for yourself, and then you can edit the copy as you wish to. So you wouldn't edit our version. You have this one for you to edit. And we've been really intentional as well about integrating careers into all of our resources, because we know that you as classroom teachers have also been asked to help your students explore a variety of careers, and none of us is an expert at every career. So we're hoping to help you out, at least with energy careers here. We've partnered with Slipstream, and actually just yesterday they came out with the 7th in the series of videos on clean energy careers, and built out of that as well, associated with it. In fact, I can, let me admit that person. If you click on that, you'll be able to access the student worksheets that go with it. So the students can watch a video and then and report back to you sort of what they've learned about that career as well. And we really would appreciate it if you do use one of our resources, that you would also give us feedback on the resource so that we can continue to improve the work that we are doing here. I'm not going to go into great detail on the dashboards and such. We can come back to that and look at the dashboard that is used in this particular lesson. Let me hide this panel. Let me see here. That's but yeah, we can go back to looking at that, because I think we're going to get a chance to look at what Oregon has, and if there's more questions, we can come back to that and explore the types of data and the inquiry questions that you might have. But I do, just in a moment of like sheer exhilaration, we have a new and updated map of solar dashboards of schools in Wisconsin. I just want to share it with you because it's very much in draft form, but this is super exciting for us because it's a map of all schools with solar. That's the yellow dots, and the green dots are all schools with online dashboards. And we're starting to work out the kind of how we're going to present it. So this is installed megawatts by utility, a number of schools with solar by utility. So I'm going to be building this out over the, hopefully by the end of the week, because we're hoping to use this as part of our argument to school board members at the state education convention next week. But this is also part of maybe the conversation later on, is how do we bring GIS into the classroom with middle school students? So this is where part of my day has been spent as well. Excellent. So going on then to our next bit here. Are you guys, Chris and Nate, ready to start sharing, or would you like me to share the Oregon Middle School Solar Dashboard?
If you'd like to do an intro of that, feel free, and then we can go to our slides. Okay.
And before we go into the Oregon Solar Dashboard, are there any questions about the KEEP lesson that I just gave a quick overview of at this point? All right. Well, I'll bring up the link that would take us to here, and if Gina, if you could share the link for Oregon Middle Schools in the chat, which you may have already, but I have not. So this is just looking at their live dashboard production. All dashboards are, each company's dashboard is going to look a bit different. Oregon Middle School uses Solar Edge. There's also eGauge, which they'll all look a little bit different, but most of them are going to have similar information. And at the middle school level, the amount of the type of information you need is not going to be maybe as detailed. You should be able to get to the what you want your students to find in there as they explore what's the information that you ask them to find. So here we're looking at the entire month of January, so we can toggle over and take a look at just today what their solar generation was. So today they generated 7.4 kilowatt hours of electricity from their system. Currently, they're producing 0 watts. So if you're doing this with students and it's 0 watts and it's the middle of the day, that should raise a red flag, right? You'd expect that there would be there'd be some generation, but the sun has set, so nothing is going on. This type of dashboard also tells us how much energy has been generated this month, as well as over the lifetime that's there. And you can then take students to take a look at it over different time periods as well. So here, this can give you some questions. I won't tell you. What are some questions? You can either put in the chat, or we're not a whole bunch of people here. You can unmute. And what are some questions you might ask students if you have them look at this data based on the generation that they're seeing there? Looks like there's a lot of generation today. Not so much on whatever day that was, the 8th, Saturday. What was going on? You can take a guess if you're not sure. I don't give grades. I'm gonna call you out, Stephanie. If
I was gonna say cloudy versus like a sunny day, maybe. I really don't know a whole lot about solar.
Yeah. But there you go. That's telling you a little bit about the weather. And so you can have your students go back and take a look at the weather on a particular day, which that's a different data set, but you can take a look at that. But you can also have them make predictions into the future. So this is today's weather. Tomorrow and the next day are predicted to be cloudy. So if this is iterative, we can also have students, predict how much electricity is going to be generated in subsequent days. The Solar Edge also gives a tally of what the environmental benefits are. So by producing this 295 megawatt hours of electricity, this much carbon emissions has not gone up into the atmosphere. So if we're talking about, the environmental benefits of having solar on schools, this might be a calculation that you'd like your students to dig into a bit more as well, or carbon sequestration. So if we're not emitting that carbon, how many trees would it take to absorb that carbon out of the atmosphere? It's kind of the flip side of that coin. Another bit of data that you could point students to, and you might also be able to relate this back to the map I was showing you that I was all excited about. The key paths of all schools with solar is when was the system installed, and what is its capacity? Like at peak, on a perfectly sunny day, if every one of the panels in the array is working optimally, it can produce 62 kilowatts. So that's something, some schools are going to make a lot. And then Wisconsin Public Service, they've got lots of schools with solar, but most of the systems on the school are 2.4 kilowatt systems. So that could be another comparison that could be drawn. And then the Solar Edge is really nice too, because you can actually go back in time pretty nicely. School districts have to subscribe at different levels, and Oregon pays to be able to go back in time a good chunk of time. So you can have students compare November of one year to November of the prior year and look at changes that might have happened as well. And here we have, you can look at it temporally as well. And this is a really nice comparison to do, where you can see that there's greater generation happening in the summer months. So conversations again about why that might happen. And often you will get the answer because it's hot outside. That is not the correct answer. But it does share the correct answer with why it's hot outside. So, so there's some nice conversations that can come out of that. I should be quiet because we really want to hear from Chris and Nate, who have lots of exciting and fun things to show. But before we move on, any ideas that have been sparked or questions that have come up, things you want Chris and Nate to talk about?
I did see that someone asked a question about what's the optimal time in the chat to generate electricity, and that'll be something we'll actually get to in our slides as well. So good stuff there.
I'll let you take it away.
Okay. Coming through okay?
It is.
Okay.
Thank you.
Well, I'm Chris Mitchell. I'll let Nate introduce himself here in just a little bit. Thank you for the opportunity to share and collaborate and to learn. We're hoping to learn some stuff tonight too. We don't have all the answers, and we'll probably just learn some stuff right there as well. So we're excited to share some of the things that we do. We're really just going to share with you the things that we do with our kids, right? We didn't reinvent the wheel for this presentation. The slides that we share are the same slides that we share with our kids in class for the most part. Nate?
Yeah, hi, I'm Nate Mahr. I'm lucky enough to work with Chris Mitchell. I do like that piece. What we really want to stress is this part about the cooperative planning and and working with our colleagues and partnering with as many people as possible. That's what actually makes it fun, and that's what makes it ultimately good. You can leave it better than you found it. I've reinvented a wheel. I don't think I've ever even used the wheel that I made myself at all, ever. So we are excited to be able to share with you, because we want people to take away from this that it really is this this collegial working together that allows us to do fun and good things for our students, whoever your student may be, and we definitely we're learning as we go. So this is a picture of the solar array on top of Oregon Middle School. We worked, a group of teachers worked with our administrators, including our business manager, to be able to get this put on and getting the numbers crunched, and then sharing with how we could use this with our students, and everything that we said essentially we were going to do, we've been doing, and then some, because the technology, as far as the solar dashboard, it allows us to really monitor what's going on, and then also it allows us to dive into data analysis, which is really important for anybody to know. And it's specifically, we've got science standards that deal with working with data. Another thing with respect to why our energy production is fairly low is we've got a lot of snow on our panels. I mean, those are all relative numbers, and looking at the scale on a graph is an important part about looking at a graph. We've had snow on our panels for quite a while, and even though our production was jumping today, that's just because some of that snow is finally coming off. It got above freezing today, at least in southern Wisconsin, for the first time in actually quite a while, kind of coming out of our first really big cold snap. I don't know what it was like up in Point today, but we got, we were getting close to 40 degrees, and it was good snow, snowman making weather. So here's just a closer look at our panel and our array. There's 198 panels there, been there for about 5 years. And what we're really getting at here is that we are integrating the data that we're getting from our solar panels into multiple areas of our curriculum. And one of the running themes, like the running theme throughout any science course, is the concept of energy. And we build, we scaffold things. I guess that's the lingo that's used to bring our solar data, our solar energy, our electricity that's coming from the panels, bringing that to the concept of light or electromagnetic radiation, scientific modeling, the ideas that scientists use to explain and make predictions. And then the Earth, Sun, Moon system is where we're really bring the solar data to bear. We highlighted that. We'll go into more details about what that is, and that ultimately leads then to the area of hope for the future. So when we talk about climate change, the hope for how we're going to solve this problem, to mitigate this problem, and then how that impacts then the weather. So weather and weather forecasting. The fact is we have weather because the Earth is unequally heated. Our solar dashboard can get us data that suggests why the Earth would be unequally heated.
Yeah, so Nate and I are going to share some of the things that we do throughout these units, these standards that we assess. Just a couple things, because we could be here a long time. This was actually an awesome opportunity for us to kind of rethink like the sequence of the things that we do as well, and are we doing the right things at the right time? So I'm going to start, we're not actually going to share something specifically from unit energy, but we did want to share that we are very, very intentional about making sure our kids are aware of the photoelectric effect. We do this specifically within our unit on electromagnetic radiation or light. And we weave it into our discussion of the dual nature of light. So this is the one instance where light behaves as a particle. And that's a discussion we have with our kids. It's a great opportunity for us to discuss the process that actually causes these electrons to move in panels, right? So it's kind of the beginning of what we do, right, with the kids as we build up to our work with the panels. And that was just something I guess we just did a couple of weeks ago. We're jumping ahead here some now too. So Nate mentioned a lot of the work that we do, specifically solar, woven into our unit where we talk about the relationship between the sun, earth, moon. And one of the very first activities that we do is we have our students explore data set that shows them the distance between the earth and the sun. And they find out quickly, they produce that graph. We see that those blue dots, which represent the position of the earth, the sun is on the inside there. Of course, it's not to scale. We see that those blue dots really don't change significantly from the sun. And the kids actually find that we're closer in Wisconsin to the sun when we're the coldest, if you can see that fine print, right? So we eliminate or rule out, you could say, the distance between the sun and the earth as being a reason for why our temperature does change throughout the course of a year. Nate, if you ever feel I forget something too, feel free to chime in.
Sure.
We figured along the way we'd share some of learning targets that we have for our kids, just so you kind of get a sense of the goals that we have for our kids on a daily basis. So this is kind of something that we do at the beginning of unit on sun, earth, moon. I'm going to talk through this, and then Nate will actually kind of talk through more so the sun angle lab and what we do sun domes. But we do spend some time up front investigating the patterns that exist at a location above the equator and a location below the equator. And the first one that we do, we take a look at Madison, Wisconsin, which is about a 10-15 minute drive for us north. So it hits home. It's personal. We have the kids look at data sets, and they're just responsible in this chart for filling in like the cells with a high, a medium, or a low, depending on how big the numbers are. Trying to keep it simple for the kids, right? They don't have to focus on the numbers to see the trends. And they already kind of know what it looks like around here. But we look at these variables about how high is the sun in the sky, how long are our days, the average temperature, precipitation, how long shadows are, and we identify, well, what seasons are those. From there, then we compare it to a location below the equator in Australia. And the kids see that they're essentially just reversing the highs and the lows throughout the course of the year. So they come to a quick understanding that in Wisconsin, when we're experiencing like our summer, Canberra is experiencing their winter, right? So seasons are opposites, right? So that's a really, really important observation we want our kids to note right up front. And then we summarize that. So Nate is going to spend some time now. As we move ahead, we really get into the specifics, and they're actually responsible for the observations on their own, not necessarily just taking a look at data sets.
Right, so this is referred to, we just call them the sun dome. So this is a seasonal sun elevation pattern. So we can actually take our students out and have them take a position of the sun, usually take it about a month or so apart, and then we provide them this data set. So that black line across there, you can see the solstices are marked. Okay, so the sun's highest in the sky. This represents the sky. So an observer would be at the center of this, March 21st, September 21st. The equinoxes are in between, and then the sun's at its lowest, then it stops on December 21st, the winter solstice. So if we go and take a look at this from the perspective of an observer here, so you're standing on the inside of that, we share those data sets then with the students. So they're looking at the data. So everything's about observation and coming back. When we talk about scientific models, again, we're talking about the ideas which allow us to explain the data patterns, and then they allow us to make predictions. So you can see then sun highest on the summer solstice, sun lowest on the winter solstice, and right in between on the equinoxes. Ultimately, we have to devise an idea, a scientific model that allows us to explain this data, including the data about our seasonal differences, 6 months apart, max to min, and then, Canberra, Australia has got the exact opposite. So how can this possibly be? We know that the sun is not moving, but it appears to move in the sky. And we do point out that, the word solstice means sun stop. Words matter, and the two words together makes sense, right? The sun stops getting lower on December 21st on average, and stops getting higher on June 21st. And it's right in between there. So when we start bringing in this solar data, we're looking for students to understand that the angle makes a difference. Okay, so which angle is going to make to get the most electricity off the panel? We do remind our students that the energy is not created or destroyed; it is simply moved around. We call moving that energy around doing work. So the sun's light is going to do work on those panels and kick the electrons off the panels through the for the photoelectric effect. And again, we're constantly just coming back to the scaffolding and building of this large knowledge base. So the energy is the same energy. It's just now energy stored electrically as it comes off the panel. Okay, so we say we're going to generate electricity. Okay, we're not making any energy. So ultimately then we want our students to be able to explain, well, why does the direct versus indirect rays cause certain areas of the earth to have higher temperature? So we're tying this back now into temperature. We'd established what temperature was earlier in the year when we were studying energy and particular particle motion. So the experiment then is we have our students make some predictions. We're going to test those predictions, test those claims. This is also an opportunity to bring in the concept of a null hypothesis if you so choose. And scientists don't prove anything. They simply rule out possibilities until you're left with whatever standing that then is. The understanding is accepted as the way it is until we find additional data to change our thinking, to change our model. So you can see there the setup. We take a fairly small solar panel. We hook it up to a multimeter. We use voltage to determine how much energy is coming off of that panel. It's set up on a basic ring stand setup, so you can change the angle of that. So we do have our students identify our variables. Again, we're tying this right back into key concept standards of science, which is a student should be able to set up and perform a controlled experiment. So independent variable, dependent variable. We would have done this many times before getting to this particular experiment. And then we go ahead and we're going to go ahead and test that independent variable, which is change of the angle of the sun on the panel. So I think this next one then, Chris, we have the video of this. So we hired some stooge to narrate this. If they sound a lot like me, that's simply coincidence.
Okay, let's check out the video here. Give you a really inside look at a lab that we had to do because we were delivering it to kids at home.
For this demo, we have a small solar panel, and I have hooked up to a voltmeter. So this voltmeter will allow us to keep track of the energy that's coming off of the panel. The higher the number, the more energy is being generated by our solar panel up here. And I've got it set up on a ring stand so that I'm able to change the angle that the solar panel is to the sun. So I placed a protractor on here with a line hanging down that allows me to change the angle. And what I'm going to do is I'm going to change that angle, and we're going to take a look at how the volts on the voltmeter change as I change the angle. So the sun is off to this side, and as I turn my solar panel, then I'm going to go away 10 degrees, 10 degrees, 10 degrees, and then I'm going to come back to my original position. My line's hanging vertical, and then I'm going to go 10 degrees towards the sun, towards the sun, towards the sun. 10 more degrees, 10 more degrees, 10 more degrees. The time right now is 2:45 p.m. I'm going to show you a technique by which we're able to determine the angle at which the sun is striking the solar panel. And what we're looking at is how close to the vertical the sunlight is to striking the panel. You can see if I cover the panel then, and we're going to drop that number on our voltmeter drastically.
So that setup, then be able to throw that together pretty easily. I know we were discussing the possibility of putting together a kit that teachers could check out if they did not have that setup, so that they could run that. They could run the data collection. So we do have our students then graph that data. We're highlighting the panel angle then that had the most electrical energy coming off that panel. And then we're going to take that data, that maximum, and we're going to be able to do a little geometry to figure out, well, what was the actual sun angle on the panel that was able to generate the most electricity. So we get a chance to, again, practice those skills. And reading a table is definitely one of those skills. This is one where students and adults alike, they look at this and they freak out. We can train our students up on, first step is keep calm and determine what are on the axes of a graph, okay? And take a couple deep breaths is also fairly useful. So what we're comparing is the solar elevation, so the height of the sun in the sky, which they would already know about from that sun dome data. And we're going to compare that then, we're going to compare that to the time of day, essentially. So finding that intersection point then, the solar elevation, we find the date, we know the time. And what we're finding then is we can use some estimation skills to realize that solar elevation at that time and date, hey, is, well, 50 degrees. So those numbers then, we're going to bring that back, do our geometry, and we work with our students. We talk them through this. Essentially, it looks like this then. So we can find, hey, through that geometry, that if that sun elevation is 50 degrees, yeah, you can see, I don't want anybody to have nightmares or go back and break out into cold sweats about geometry proofs from way back when. But it does allow the students to start to realize, I see how it works. I see it, like the sun's coming to the panel. We had established it's 90 degrees. We know the sun elevation is 50. So here we can see then, we can work this out and realize, oh, it is 90 degrees on the panel. That caused the most electricity to come off that panel. Okay, so you can't create or destroy energy. So there must have been more energy coming to the panel to get more energy off the panel. Okay, it has to follow that law. So we know that this is max. Okay, so there's something not magical. It's just basic factual science. Maximum angles, 90 degrees, are perpendicular, direct rays on the panel. And then we move forward then as follows.
Yeah, so the next
I'm curious, how long does it take you to do this? I mean, to do the precursor of the experiment, help the students set it up, they collect the data, they do the analysis, and then they draw that conclusion. Like, over what period of time would that happen?
So the period of time we would get the data, the setup and the data collected, we can get that done, and then get the graph done. We get that in 1 day, and then the next day we come back and we're able to use that that chart, work through that geometry, and then this is actually a tie-in back now to something that has to do with, again, just spreading out the rays. So that then would be the follow-up day. So essentially it takes about 2 days. Now, when we actually go back to the modeling for the seasons, we have the students use props. So, you know, a sun and an earth prop, they've got to work through the tilt of the earth, and you know, and why, you know, how that's all going to work out. That's an additional day of work as well. So probably, I would guess there's probably, what, Chris, there's probably 4 days, hey, to get through the seasonal stuff along with the solar panel. I mean, it ends up, yeah, there's all these little moving parts that we kind of pull them all together, kind of for the aha moment. But this next piece then, which Chris will describe, as you can see from the diagram, then, you know, well, why does direct rays, why would that make a difference at all?
Yeah, so we make sure that we explore that why, right? Why those perpendicular direct rays actually do make the difference. And all comes back to energy and area, right? In both pictures there on the left and the right, the same amount of energy is coming down from the sun. In the instance on the right in December, it's spreading out more. So any given area then on the earth is experiencing less energy, right? It's just more spread out, versus here, all energy is in a smaller amount of space, right? So it's all about per area. And, you know, we all know ratios are tough for kids, but it's one of those instances where we're talking the amount of energy per given amount of landmass, right? And how much energy is concentrated there. And that's really, really important. It's also important for kids to realize, and say, like Wisconsin, we never get the rays to be perpendicular, right? We never actually see the sun straight above our head. That's something we get to eventually with our modeling. So we demonstrate this actually with like flashlight. We're actually not going to play video here, but actually create a grid on our board, and we shine like the flashlight on our board directly versus indirectly. And I usually have a kid actually come up and trace the perimeter of like the brightness, and they can see that, oh, well, the flashlight is not producing more energy, not allowing more light to come out in one instance or the other. It just spreads out more. I think that really allows those kids to make that connection to, it's all about like the spreading out process of energy per amount of area. So this is just kind of like the summary. We get to this at some point. And then the next step is actually like a modeling step. So this is where we actually get into taking a look at the patterns and then starting to actually put like an earth and a sun in our hands and try and figure out, well, what actually makes angle change throughout the course of the year. And Nate is going to spend a little bit of time. We're finally to like our dashboard stuff.
So that's that modeling piece then. So the students will have to work through, and they'll have to take a prop Earth and then move it around the sun to realize that it's the orbit of the Earth on a tilt that's going to cause the sun to appear to go up and down and change then that amount of solar heating, which causes those temperature differences. So we're finally to the solar dashboard. Hey, yay. So I'm sure someone's like, yeah, when are you going to cut to the chase already? So anyway, the solar dashboard by itself, it's just a graph, right? So how we use it then, that's the part where, you know, we make it meaningful, and our students can play around with the dashboard too. That's always up to, you know, us as instructors, and we're always learning different ways to get more out of the data. But we come back repeatedly to the concept of sample size, hey, and time, and again, looking at the axes on our graph. So we've got our months down there, and we've got along the, you know, the x-axis is our time, and then the y-axis then is the output from the panel. So we can look at it in terms of days. So now we're looking at, 1 month of approximately 30 days. So we're looking at, November and December of this past year. That's one way to look at it. So we can see each of those days within a month. And then here we go, we zoom out, and so we go big scale. So a whole heck of a lot of months is 4 years of data. And this is now how we really start to, this is where we really start to apply the data to start to explain some things. Because as you look at this, then you can clearly see, hey, that we're having our peak production is in June. Now the students have already established that peak heating is in June. They've already established that, oh, that's summertime, is we max out, in June in the summertime, and you can see how low it is then, as we trail off towards, well, the winter, particularly this, this time of year. So as we look at the pattern, then we can see this repeating. Again, we talk about patterns in the data. It's all about patterns. Sorry, pun intended. It's repeat. That's what it is, a pattern. So they can clearly see we've got this, it's just lump up to June, drop down, peaks in June and valleys in December, January, and it repeats year after year. So this now is where we get our payout, because our students, as Chris was saying earlier, we have these data packets that the student look for. One of the things they take a look at is the maximum angular height of the sun. Okay, so they're looking at this and they can see, it's like, oh yeah, that's like one of the lumps, okay, on our solar dashboard. That's one of the yearly lumps, the peaks and valleys of solar electricity generation. Looks just, it's like the same thing. It's right there. So this is not solar though, electricity generation. This is just the height of the sun. So we're seeing a strong correlation now, and we could actually start moving that into then causation, because we know about the heating. We've taken a look at that. We know about the electrical energy, and they've seen it before. So it's like, oh, the sun angle matters. It matters. Oh, good, Chris. You're making me feel good about myself now. You're mic'd up. That's what I usually.
It's been a while since I've had the opportunity to do that with my kids.
Yeah,
I just
it feels good.
You know what I was saying. So I'm going to run through this actually fairly quickly here, just to leave some time at the end for some questions or some feedback. Probably what absorbs the most time when we get to our sun, earth, moon are 4 or 5 times where we actually put things in our hands. We model, we move them, and we try to come up with explanations. One way that organize what we do know is we call it a P.O.M table. A phenomena, the P, the object, the O, M, the motion. We write those things down so it's organized in a way that we can recall what observations we've made, what objects are involved in the explanation of those, and how do they move relative to one another. And then from there, we actually, we will give the kids props, right? And they're responsible. And I couldn't find a really good picture, but those props allow them to actually see throughout the course of the year if the earth is at a tilt. That affects the directness of those rays, right? So we're going to get really, really direct rays in Wisconsin at this star here, but in winter, when tilted away, we're going to get very, very indirect rays, and that energy is going to spread out per unit of area much, much more. And then the in-betweens, we have spring and fall, right? Where like the rays are somewhere kind of in between. And they sketch this. So we have some pretty high expectations for a sketch. This is a tough one, right? So this takes some time. This might take half of a class for us to get all the information down in a sketch. This is student work. So this is just a picture I took of an 8th grade kid that we have in class. It allows them to have a good visual in their science notebook of really what modeled in class. And it allows it, I think, like to stick in a different way. And then we put it all together in words, right? So we summarize the things that we know, the direction of the orbit, how long it takes, the tilt of the earth on its axis, the position of the sun relative to the earth. We make sure we don't include things that aren't involved, like the moon, that extraneous information, right? And then we continue, and eventually we say, as a result of these movements and these positions, well, what do we actually get, right? So we see the sun's highest in the sky on June 21st, and that's also when the rays are the most direct. So we really ask a lot of the kids, like, summarizing this. We do this together, but it takes some time. It really does take some time. And then we eventually have a conclusion, right? And our conclusion is all based on a seasonal explanation, right? Of when the northern hemisphere, in this case right here, is tilted away or towards the sun, the dates, and how that relates to the position of the sun in the sky. Nate, I think you got the last two slides here. And this kind of gets into our last unit of the year that we never have enough time on.
Yeah, so ultimately, near and dear to my heart. So I actually am a trained meteorologist, so please don't hold that against me. But it really does come down to, we have weather because the Earth's unequally heated. So the students can actually start to understand this concept of, they can see that the most direct rays they're always at the center of the Earth. So, you know, in the equatorial regions, you know, the tropics, marking where the sun stops going directly above. So we're going to have warm spot at the tropics. We're going to have a cold spot at the poles, and then, you know, it's off to the races from there, because that air is going to mix. And we had already established, you know, some things about the details of convection from our energy unit. So now they can actually start to realize that, you know, heating causes temperature differences cause pressure differences cause the wind. And we'd already established then the concept of the phase changes of water and how energy plays a role there. So we're talking about, you know, freezing, melting, evaporation, condensation, and we can then start to explain various weather phenomena. Okay? And again, it all comes back to the energy. It comes back to the heating, and, you know, to come back to that, answering the question about, you know, what time of day is the time for generating that electrical energy off a solar panel. It's like, well, it's whenever the sun is the, you know, closest to vertical on that panel. So that's going to be noon. Hey, high noon, right? Sun's at its highest position at noon. So whenever we can get that sun as close to vertical on that panel is when we're going to generate the most electricity off that panel. So these are some resources. We certainly looking for feedback at all times. I think that's probably our one of our best qualities is we'll admit to you right up front, we don't know much, and but we're looking to learn. See, Chris is laughing because he definitely knows I don't know much. But anyway, and we're always looking, you know, stay curious, and you know, we want to you know, ask questions, and we all improve our craft. And as Chris was saying earlier, just going through these slides is really helpful for us to be able to have to think through, you know, how do we best address, you know, the standards that we're trying to teach? How do we address those learning targets? And that's the reflective nature of, you know, we're all in education in some way. The reflective piece is really, really important, and it helps to have a good partner. Find yourselves partners. It's more fun, and they'll help you reflect and do a better job.